Section 12.4 is dealing with angle measures and segment lengths. So our first theorem is that the measure of an angle formed by two lines that intersect inside a circle is half the sum of the measures of the intercepted arcs. So here's my angle formed by two lines that intersect inside a circle. They do not have to intersect at the center of the circle. Anywhere in the circle is fine. So angle 1 is half the sum of x plus y. So the measure of angle 1 is half of x plus y, the intercepted arcs. That's theorem 12.13. We have one that is similar we're going to look at before we do some problems. And this is theorem 12.14. The measure of an angle formed by two lines that intersect outside of a circle, so here's the difference. The two lines intersect outside the circle, is half the distance, again, but this time, sorry, I read it wrong, is half of the difference of the measures of the intercepted arcs. So instead of the sum, it's the difference. Measure of angle 1 is 1/2 of x minus y. So let's try a couple of these real quickly. So here we have a situation where x is formed by the intersection of two lines. We know the intercepted arcs. So the measure of angle x is going to be 1/2 of 92 plus 50, which is 1/2 of 142, or 71. So measure of angle x is 71 degrees. Over here, these two lines intersect outside of the circle. So we can say that the measure of angle, it's already given to us. So 20 degrees is 1/2 of the difference of 100 minus z. I'm going to multiply both sides by 2 to eliminate the 1/2. Subtract 100, so I know that z is 60 degrees. This arc z is going to be 60. So that's the first two theorems. They're pretty simple to use once you know them. Theorem 12.15, for a given point and a circle, any point, inside, outside, whatever, the product of the lengths of the two segments from the point to the circle is constant along any line through the point and the circle. Let's take a look at what that means. So, given point, the product of the lengths of the two segments from this point to the circle. So one segment is D, the other is C. From this point, I can do any other two segments, A to B. I could use any other segments that I want. I could do E to F. But all of these pairs of segments, A times B will equal C times D. The product of the segments from the point to the circle is constant along any line. All right, so again, I'm going to draw two lines from my point. So the distance from this point to this side of the circle is W. The distance from the point to the other side of the circle is x plus W. So the product of those two segments will equal the product of the segments along this line. Again, the length here is z plus y times the distance to the other edge of the circle is just y. Here, since it's a tangent line, the distance from here to here is the same for both edges of the circle because I'm only going to touch it in one place. So I'm going to do t times t equals, again, the entire distance, the distance to this side of the circle, times the distance to this side of the circle. So those are the three different cases that we can have for this particular theorem. Let's do a couple of examples. Oops, I need the whole picture. So on this one, here's my point. I've drawn one line this way, another line this way. So the product along this line to the far side of the circle times the distance to the near side should equal the product of the distance to the far side, again, times the near side. So let's see. The long one is 17 times 5. The long one here is 6 plus x times 6. So 17 times 5 is 85, equals 36 plus 6x. Subtracting 36, I get 49 equals 6x. So x is 49/6. Let's look at the next one. Here my point is inside. So the distance to this side of the circle is 2 times x has to equal 3 times 6. So 2x equals 18, x equals 9. So the math is pretty simple. It's, again, learning the new theorems and making sure we have them memorized. They might want to go on your theorem sheet, but that's it for the lesson.